Moon vs Mars 2021. There is a great deal of debate over whether we should establish a permanent human presence on the Moon first, or go directly to Mars. In order to weigh these two possibilities, let's take a look at some relevant considerations. The Moon has no atmosphere. The surface of the Moon is engulfed by the vacuum of space. It has no appreciable atmosphere. Though the atmosphere of Mars is only 1% the density of Earth's, the difference between no atmosphere and some atmosphere is significant. On both the Moon and Mars, the risk of radiation and meteor impacts is significantly higher than on Earth. The thin atmosphere on Mars, however, does provide meaningful protection from some radiation, and from small asteroids up to 1 meter in diameter, known as meteoroids. The Moon has no radiation protection whatsoever, and its surface receives heavy bombardment by meteoroids traveling as fast as 47,000 km/h. These meteoroids, which can cause significant damage to structures, would not survive entry into the Martian atmosphere. Arguably, the most important ramification of having some atmosphere on Mars is that it provides a valuable resource. Through various processes, the Martian atmosphere offers an abundant source of breathing air and propellant. The Moon lacks this crucial asset. Day-night cycle and temperature extremes. A day on the Moon lasts for 28 Earth days. Though humans on both the Moon and Mars will spend much of their time inside pressurized habitats, by necessity, this drastic transition to the day-night cycle of the Moon will introduce a further complication to the management of human health. Sleep is essential to our physical and psychological well-being, and light exposure modulates our sleep-wake cycle via our circadian rhythms. Mars, on the other hand, has a day-night cycle that is very similar to Earth's 24 hours plus 40 minutes. Partly as a result of this drastic day-night cycle, the Moon also experiences far greater temperature fluctuations than Mars. The Moon alternates between 127 degrees Celsius in sunlight and minus 173 degrees Celsius in darkness. This places further restrictions on the design of lunar habitats and infrastructure. Low gravity. The Moon has very little gravity. Although the effects of partial gravity on human health remain uncertain, there is good reason to believe that the closer we can get to Earth gravity, the better. Research suggests that biological systems will tolerate the relatively stronger partial gravity of Mars better than that of the Moon. Physiological impacts aside, the transition to partial gravity will be a psychological challenge. With more than twice the gravity of the Moon, we can expect that the shift to Mars gravity would be comparatively easier. Transit time and reduced existential protection. The primary attraction of human missions to the Moon is that it is close. The shorter journey results in less radiation exposure in transit, far less communication delay, and opens the door for rapid egress or rescue from danger. Conversely, the distance to Mars is often discussed in a negative light because it adds mission complexity and risk. It is important to consider, however, that the large distance between Earth and Mars actually provides increased existential protection. The relatively small distance between Earth and the Moon, on the other hand, offers relatively less protection. Consider an impact from a large asteroid. This is a particularly applicable scenario since an event of this kind has already resulted in at least one major extinction event on our planet. These impact events are capable of ejecting a substantial amount of rock into orbit, thereby potentially placing any lunar settlements in danger as well. In fact, it is estimated that for every 100 square kilometers of the lunar surface, there is 20,000 kg of rock previously ejected from Earth. This same reasoning also applies to gamma-ray bursts, which are also suspected to have caused mass extinction on Earth and other cosmic threats. Additionally, the close proximity of the Moon would mean an increased susceptibility to geopolitical conflict unfolding on Earth. History is unpredictable and volatile. Just as a crewed spacecraft can reach the lunar surface far sooner and more easily than the Martian surface, so too can implements of warfare. Thank you for watching.